All right, today we are going to look at lesson 1 on ratios. That word is pronounced ratios, not radios. Go ahead and get your name on your notes there. All right, let's look at some basic background for ratios. To go from input to output this way, we're multiplying by 3. So to go this way, 4 times 3 is 12. 6 times 3 is 18. The opposite of multiply, if we're going the opposite direction, is to divide. All right, these are ratios. 4 to 12 is the same as 5 to 15, is the same as 6 to 18. Same ratios. Here's another way to look at it. Aldo is building a fence around his garden. For every 3 feet of fencing, the cost is $21. Complete the table below showing the length of fence and the cost. So 3 to 21. As you can see, as we go from feet to cost, we're multiplying by 7. So 7 to 49 and 10 to 70. Those ratios are all the same. Going up then, we're going to divide by 7. So 56 divided by 7 is 8. 35 divided by 7 is 5. Okay, what is a ratio? A ratio is a way to write the relationship between two values. And we can put in parentheses two numbers. That's how they're related. All right, there's 3 different ways to write relationships. And for my values, I'm going to use the letter A and the letter B. So we can write it A2, T-O-B. We can write it A colon B. That's a colon. Or we can write it as a fraction, A to B. Okay, so an example of this would be, well, let's use this one up here with the numbers 3 and 21 here. So we could say it's 3 to 21, or 3 colon 21, or 3 over 21 as a fraction. Okay, so let's write this following ratio 2 other ways. 5 colon 4 is the same as 5 to 4, or 5 over 4. All right, now why would we write ratios? We use ratios to compare parts to parts, or to compare parts to a whole. And this is when we would use the fraction mode. It doesn't make sense to write it as a fraction, like step 3 here, if you're comparing parts to parts. All right, so looking at this next, I have 4 females in my family, including my dog, and there's 7 people total. Write as parts to part. So parts to part would be 4 females. I'm going to put a colon here, 2, 3 males. Okay, if I'm doing parts to a whole, 4/7 of my family is female. Okay, or I could have said 4 females to 7 total. Those would be a couple ways to do that. All right. We're going to do several examples together today on different ways to look at this. Write as a ratio of all the marbles to white marbles. Since we read left to right, we write our answer left to right. So first I'm going to put all marbles. And these are my marbles. There's 12 marbles total. So 12, 2, and then white, 7. I could have written it 12 to 7. I could also have written it 12 over 7, though that way's the worst when we do parts to part, or wholes to part. Okay, what is the ratio of black marbles? It's first to the white marbles. So 5 to 7. Okay, remember, whatever value you read first, you write first. Ratio of male students to female students in this room. We're not here right now. We'll cross that one off our notes. Okay, there are 11 apples in a basket. 3 of these are green. The rest of them are red. So good, it'd be important first to know how many are red. If 3 are green, then there are 8 that are red. And I know, I wrote that in green. Doesn't make sense. Ratio of all apples. Okay, that's what's written first. All. So 11 to the red apples. 8. Ratio of green apples. 3 to red apples. 8. Check out my technology there. Using colors correctly. Okay, let's look at another example. Ratio of apples to oranges in an orchard is 7 to 5. Sometimes it's easier to write off to the side so you can see this. 7 apples, 5 orange. Okay. Check all the statements that must be true in the statement above. When I underline like this in my notes, you don't have to do that on your notes. For every 7 apples in the orchard, there are 5 oranges. Is that true up here? Yeah, that's true. There are 7 apples to every 5 oranges in the orchard. Yeah, that's true too. There are 5 apples to every 7 oranges. No, that one's not true. For every 5 apples in the orchard, there are 7 oranges. That one's also not true. We also can't say there are only 7 apples and 5 oranges. It's just telling us that that's the ratio. All right. Next portion. Just like fractions, we often want to simplify ratios. We know that it's easier to use smaller numbers. So if we had 4 boys to 6 girls, to simplify that, we have 2 boys to 3 girls. That's an easier ratio for us to think in our head. Okay, so question 4 here. Write the ratio as a fraction in simplest form with whole numbers in the numerator and denominators. It's another key point, whole numbers, and we'll get to that. So we have 6 and 28. So we could divide them both by 2. 8 to 14. But again, they're both still even. We can still divide by 2. So we have to make sure we simplify the most. 4 minutes to 7 minutes. We could have right away found that the greatest common factor was 4. But I just divided by 2 and divided by 2. Ratios usually use whole numbers. Change fractions or decimals by multiplying or dividing. Okay, so here we have a half to 8. Half is not a whole number. So we can get half to be a full number to multiply by 2. So we'd have to multiply that by 2 and 8 by 2. So that's the same as 1 to 16. And that is simplified. Here we have 2 tenths to 8 tenths. Well, since we have decimals, we know we can just multiply them both by 10 to move the decimal over. So that would be 2 to 8. But that is not simplified yet because they're both even. So simplified would be 1 to 4. If we were really clever back here, we could multiply both of these by 5. But I just did 10 since it was easier. Okay, so let's look at this next one. Write the ratio as a fraction in simplest form with whole numbers in the numerator and denominator. Okay, so 3.5 liters to 4 liters would be the same as 35 liters to 40 liters. We could then divide them both by 5, and that would give us 7 liters to 8 liters, and that is simplified. If we were really clever, we could have gone back to the original and just doubled both of them. 3.5 times 2 is 7, 4 times 2 is 8. Lots of strategies to do on ratios here. And we're going to use a lot this week. Okay, this next and final problem for the day. Laura is deciding how many people to take to the movies. The table below shows the costs for different sized groups of people. So we're going to see if it's a consistent ratio or not. Okay, so to get from 2 to 16, we multiplied by 8. To get from 3 to 24, we multiplied by 8. To get from 7 to 56, we multiplied by 8. So the cost for each appears to be the same. Predict how much it would cost for $64. Okay, so to multiply by 8, it would be 8 in the group. 8 times 8 is 64, or 64 divided by 8 is 8. Okay, example B, a train travels from city A to city B. The table shows the distance, the amount of time it takes the train. Okay, instead of going down and dividing, I'm going to look up and multiply. That's times 8. Ooh, that's I'm sorry, that's not times 8. Let's see if I can get rid of that. My mistake. Okay, 2 times 7 is 14. 6 times 6 is 36, and 7 times 6. Okay, that's not consistent. Here you saw it took 7, here was 6, here was 6. So we don't have a similar ratio. It does not always go the same distance each minute. Trains speed up and slow down a little bit. Okay, so you can't predict 9 minutes, at least with what we're doing now, because it does not have a similar ratio. All right, so your classwork's going to have 10 problems. You need to submit these notes, and then your problems will be like what we just did. When you're looking in Alex, I do have here what this week's topics look like. They are in your ratio and unit rate pi. Mainly you want to look for the word ratio. So you could search that up. All right, that's ratios.